7.3 Solubility Equilibria. Solubility is a property referring to the ability for a given substance, the solute, to dissolve in a solvent. Solubility is the maximum amount of solute in gram or kilogram that can be dissolved in a given quantity of solvent to form a saturated solution. And the unit is gram per liter. Molar solubility is the number of mole of solute dissolved in 1 liter of a saturated solution. And the unit is mole per liter. Look at the example given. Let's say we have a cup of a bitter coffee. This is we call as a solvent. So, to reduce the bitter taste, we decide to add sugar in maximum amount. Sugar as solute. So, this will result a very sweet coffee, which is we call as saturated solution. Solubility product is a value which you get when the solution is saturated. The solubility product KSP is the product of ion concentrations in saturated solution, each raised to the power of its stoichiometric in the equilibrium equation. Means if there is any solid present, you can dissolve any more solid that there is in a saturated solution. For example, we have a saturated solution of silver chloride in water. First, we have to write the balance equation. The forward reaction we call as a dissolution. Since the reaction is reversible, so the backward reaction is precipitation. Now we learn how to write the KSP expression for the above equation. So, the KSP expression can be written as the concentration of silver ion times concentration of chloride ions. An equilibrium constant related to the equilibrium between solid salt and its ions in the solution. And at constant temperature, the KSP value is constant. But the soluble ionic compounds such as sodium chloride doesn't have any KSP value because they are 100% soluble and dissociate in water completely. Now look at two other examples how to write the KSP expression. A, we have the calcium phosphate. So we have to balance the equation first. And then the KSP can be written as concentration of calcium ion power of 3 times with concentration phosphate ion power of 2. Okay, B, we have the lead to fluoride. So we have to write the equation first and balance the equation. And the KSP can be written as concentration of lead ion 2 plus times with concentration of fluoride ion power of 2. So, as a little review about solubility, solubility is the maximum amount of solute that can dissolve in a given quantity of solvent to form a saturated solution. So, it can be in mole per liter or gram per liter. Mole per liter also known as molar solubility, which is number of moles of solute in 1 liter of a saturated solution, while in gram per liter as solubility, number of gram of solute in 1 liter of a saturated solution. Performing calculation involving KSP. We have two types of calculation. The sequence of steps for calculating the KSP from the solubility data, or it can be vice versa. Let's say, if the starting data we get is from the solubility in gram per liter. So, the first step we have to convert the solubility of compound to molar solubility by dividing with the molar mass. After we get the molar solubility, we will get the molar concentration of each ions. Then, after write the KSP expression, we can find the value. So it can be vice versa if we starting from the KSP value. So for the vice versa, starting from KSP, we have to find the molar concentration of ions, and then we get the molar solubility of compound. And to get the gram per liter, so we have to multiplying with the molar mass. Predicting a precipitation reaction. When two solutions containing ions of a slightly soluble salt are mixed, prediction can be made whether a precipitate will form or not by comparing the ion product QSP with the solubility product KSP. For any slightly soluble compound such as MX, AY is as given below, which consists of ion M plus and A minus. And the KSP can be written as concentration of ion M plus times concentration of A minus. If a solution containing M plus ions are mixed with another solution containing A minus ions, the ion product Q is given by QSP equal to concentration of M plus ion times concentration of A minus. Q has the same form as KSP, but the concentration of ions are calculated from the respective solution where the ions originates. When QSP equal to KSP, the solution is saturated, means the reaction is already at equilibrium. Precipitation will not occur. If the QSP is smaller than KSP, no precipitation will form because the solution is unsaturated, means more solid could dissolve to form more ions in solution until the QSP value equal to KSP. But the last one, when the QSP is greater than KSP, a precipitation will form until the remaining solution is saturated. Precipitation will occur. Common ion effect. Common ion is ion which is the same as the constituent ion of the slightly soluble salt. Common ion effect refers to the decrease of solubility of a slightly soluble salt due to the presence of common ion. The addition or the presence of a compound having common ion with the dissolved substance will decrease the solubility of the slightly soluble salt. This behavior is a consequence of Le-Chatelier principle for the equilibrium reaction of the ionic dissociation. For example, addition of sodium dichromate solution to the saturated solution of lead dichromate. First, we have to write the balance equation and the KSP expression, which has a value of 2.3 times 10 power of negative 13. So the common ion of dichromate ion is added to the equilibrium that causes the concentration of dichromate ion increases. The equilibrium position will shift to the left, forming more dichromate ions to precipitate. So, some of the dichromate ions will combine with lead 2 plus ion to form solid lead dichromate. This will cause the solubility of lead dichromate decreases. That's all. Thank you.